Hi everyone, this is Himanshu, and in this lecture we will study about the basic physics and astronomy. The fundamental question that have been intrigued the humans for a long time is that what is the world exactly made of, or what holds it together? And these fundamental questions, the answer for these has been discussed the more appropriately in the standard model of physics, which explain this, that every matter is made up of the fundamental particles. These fundamental particles are the quarks and leptons. The quarks are basically a very good example for that is that in a nucleus of an atom, it consists of a protons as well as a neutrons. Now these protons and neutrons are actually the made up of the quarks, whereas the electrons which are in the outer circle, they are made up of the leptons. So these are the two fundamental particles, and the interaction between these particles are governed by the four main interactions, which are on the basis of gravity, electromagnetism, weak nuclear forces, and the strong nuclear forces. But however, out of these four, the weak nuclear force and the strong nuclear force, to make these two work together, there exists a third particle as per the standard model, and which is called the Higgs boson particle. So therefore, as per the standard model, the elementary particles in the natures are the quarks, leptons, and the bosons. So this is what the standard model says. Now on the basis of that, our entire universe and the galaxies are made up of. So let's start with one by understanding the basic terms. The very first one is about the antimatter. Now we know that every known matter in the universe has an antimatter associated with it, which has the same mass, a same volume, but a different charge. For example, a proton will have its antimatter as the antiproton. Similarly, the electron will have an antimatter called the positron. So this is what the antimatter is made up of. Similar to that, a quarks. Now, as we have discussed, the quark is a fundamental particle in the universe. When the two and more quarks combine together, they form hadrons. Now, these hadrons, such as the protons and the neutrons, each and every quark has an antiquark in its own way. So therefore, in the universe itself, or we should say that in the physics, as per the standard model, there are 6 principal quarks as well as 6 antiquarks. And these are only two fundamental particles that interact through all 4 fundamental forces that we have discussed previously, that is gravitational, electromagnetic, strong nuclear force, and the weak nuclear force. And more importantly, if the basic question that people ask, that if we know about these quarks, then why it's still a mystery that we are not able to define its spin and parity. Now the problem with the quarks is that the quark exhibit a confinement principle. Now the confinement principle says that they are not observed independently, but always in a combination with other quark. So if I have to determine the properties of the one quark, it won't exist independent. So it must be in a combination with another one. And because of this, it makes impossible to measure the properties like mass, spin, and parity. So this is the mainly about the quarks that you should know about. The next one in the series will be the leptons. Now, as we have said, the electron is also a lepton. So generally, they have a fractional charge. Actually, they have no fractional charge at all. Now, the lepton in the standard physics have been described in the 6 types. The one of them is an electron, muon, tau, as well as 3 types of the neutrinos. So this is the 6 types of the leptons which exist in standard physics. The next one is fermions. Now, the fermions are basically, it includes all quarks and leptons. For example, electron, protons, and neutrons. It consists of all of them. And they have a very special property that they show the half integer spin. And they are constrained by the Pauli exclusion principle. Now, the Pauli exclusion principle is basically one of the principles in the quantum mechanics physics. It says that when the 2 or more identical fermions cannot occupy the same quantum state within a same quantum system simultaneously. So you don't have to dig a deep enough that what does it exactly means, because in UPSC exams they won't ask you so deep about this thing. So the only thing that you have to remember is that the fermion consists of both quarks as well as leptons, and they always have a half integer spin, and they does show the Pauli exclusion principle. So these are the 4 points that you need to remember. Let me highlight them. And because of this thing, it creates a foundation for building up the periodic table, and it governs the the behavior of the electrons. So this is mainly about the fermions that you all should know about. The next one that we have to discuss is basically the bosons. As we have discussed, there are four fundamental, the interaction, and out of which there existed two, the strong nuclear force and the weak nuclear force. Only till now, the boson has been determined for only these two forces. Now the boson are the particles that carry forces. So, and it has been named after the the well-known scientist Satyendranath Bose. So the previous two forces, like a gravity and the electromagnetic, we don't have a boson exist for these two, and that is the reason why we cannot say that these are the forces. That's why we call them as an interaction. But for the rest of them, for the remaining two, that is a strong and the weak nuclear force, their boson exists, and that is the reason why we call it as a force. And in present, the strong nuclear force is the strongest and the gravity is the weakest. That's enough about the boson. Now the second thing is basically a God particle. This is a theory which has been laid forward by the Peter Higgs. Now Peter Higgs suggested that particles did not have the mass just after the Big Bang. The Big Bang is when the universe was created. So as the universe was cooling down and the temperature fell below the critical point, an invisible force field got formed, which has been termed as a Higgs field. Now this field itself has a very much great property that whenever anything which came into contact with this particle, it got mass. And that is the reason why we call it as a God particle. So any particle which interacted with this Higgs field or Higgs boson has got the mass. So this is the main principle behind the God particle. And more importantly, recently the scientists at the CERN observatory, the Higgs boson decaying the fundamental particle is known as a bottom quark, which is another name given to these things. So this is mainly about the God particles. Now next that we need to know is about the neutrinos. When we say a neutrino, these are generally the massless subatomic particles. Now they generally emitted when any nuclear substance decays, or you can say more importantly, the neutrinos are the particles that have no electric charge and they are not even affected by the electric or the nuclear force, and because of that they are invisible, they can pass through any matter, and that is the reason why it is very difficult to detect them as they travel to the speed of light. So this is about the neutrinos. And recently, if you are well aligned with the news, you have seen that India has one of the Indian neutrino observatory at the Bodhi Hills in Tamil Nadu. Similarly, there is a Hyper Kamiokande neutrino detector in Japan, which is actually currently the largest in the world. So this is mainly about the neutrinos that we need to know regarding the prelims perspective. The next one that we need to know is the solar neutrinos. So as we have discussed earlier, that when the nuclear substance decays, it emits neutrinos. Similarly, the sun also has some fusion reaction within it, and when such thing happen, it also emit the neutrinos because the hydrogen nuclei fuses to make a helium in the sun, and in this procedure the neutrinos are released, the gammas are released. So these neutrinos are called the solar neutrinos. The next one is the Large Hadron Collider. Now LHC is basically was built to study some of these fundamental particles and how they interact and how they behave to each other. And currently the LHC is a giant particle accelerator which has the lying in the Swiss and the France border itself. So in this, what happens generally, there's a protons which are accelerating at a very high speed, they made to collide each other, and when the collision occurs, they result into formation of a particle that's called the Higgs boson particle. Now that is a very big discovery, but this particle which has been formed, the Higgs boson particle, now they exist for a very small amount of a second, that is a billionth of a second. So this helps us to study the dark matter and the other mysteries of our universe, and it can play a big role in this thing. So this is the main reason why we have an LHC and the Large Hadron Collider. Apart from that, there is a dark matter and the dark energy that we're gonna study in the next chapter. Thank you guys.